Alright, welcome back, Mathy. Today we are finally solving an equation. On the left side, as usual, we're going to have a complex type of algebraic expression, which is a bracket bx, either plus or minus c bracket close. If I give you a little bit of recalling, a, which is single term, also professional way of saying it, monomial, will be located on the outside of the bracket, and inside of the bracket you're gonna have two unlike terms. One of them has variable, which can be x generally, but it can be a, b, f, whatever, and we call this bracket term binomial because you have two terms. So we have, singular, monomial and binomial, and we are having multiplication relationship because there's no specific add, subtract, division, any sign in between the monomial and binomial. Unlike last time, now we're gonna actually have a right side, which is some kind of integer that you will see, or constant, if you will. Equation always have to have this equal sign so that whatever you see on the left side and whatever you see on the right side are equal together. We are going to solve this type of equation, and we are going to use model, ladies and gentlemen, for today's. Because we're using model, and even if you're not using model, we generally have to deal with two parts. Part one of the step will be always about expanding the left expression, and part two will always be about solving an equation. So in this case, solving the equation. Have that in your mind, folks. There are part one and part two. Part one is review of what we learned in the previous videos, and part two is recalling of last chapter, if you will, almost, which is repeating of Math 7 two-step equation. So let's do several examples. We're gonna do quite a lot. Example number one, or classic example number one. Why don't we do, 3x minus 1 equal to 15. Actually, 15 will make your life miserable if you're using model. Why don't we go a little simple? So something like 3. Yeah, why not? Let's get this thing started. My first step is focusing on the left side only, and we're going to create a table. Vertical side, you're putting monomial, but what I'm going to do, unlike the previous one, why don't we do, I have been doing color 1 as positive, but why not this time color 1 as negative? Because it doesn't really matter. Depends on the textbook that you choose. They even use color code. So in any case, positive 3. That means I'm dealing with positive integer tile. 1, 2, 3 small empty square algebra tile. Now x is a strip. But know the fact that if you decided to put colored as negative, be consistent. I have positive x minus 1. So positive x is one strip, negative 1 is colored small tile, like that. Now, here's where magic happens. You're combining things together and figuring out what goes inside, because that gives you expanded form of the left side. So that is our job of using model. As you may notice, it's positive and positive, which give you positive. Different color mean positive and negative, so it should give you negative, but it's positive 1 times negative 1, so it's just negative 1. Just like that. Then we will write this as 3x minus 3 because I have 3 empty strip and 3 color tile. But we're not doing mental math situations, so have that in your mind. With that, we're going to rewrite and proceed to our second part. So again, first part is expanding, which is create a table and find out what goes in between. That is our first part of the step. Second part of the step is, and we did this before, solving an equation. On the right side, now, first thing first, left side we expanded, so that goes on the left side. Right side, we have positive 3, which is, in this case, colored 1, 2, 3 tile over here. We have left side that is equal to right side. You have to deal with 0 pair first, ladies and gentlemen. 0 pair. And get rid of whatever the x having side, which is on the left side. We have to somehow cancel these 3. How can we cancel? Well, reintroduce 1, 2, 3, 0 pair, basically. I just find out I colored this part wrong. I put positive 3, which is what the question said, but I accidentally put negative 3, sorry. That's more like it. We added 0 pair, 1, 2, 3, and then this 3 was originally what's on the right side, positive 3. So we have those. 0 pair is what's happening over here. Then now what I have is I have 3x that is equal to 6. And our last step is how can we distribute our number of tiles that you see on the right side to equivalently to each strip that you see on the left side. Since I have 3, it is possible for me to distribute each of the strip with 2 integer tile. Then I get to this conclusion. 1 strip is equivalent of 2 empty tile. And that provides me an answer because empty strip, like what we decide, that's positive x, so that's x is equal to positive 1, which is equal to positive 2. So let's quickly review. First step, we need to find out expanded form of the left side. Second step, we have to find out the answer. However, to find out the answer, we have to do 0 pair first. So this is step 2. And step 3 is equal distribution of the remainder tile on the right side to the left strip per strip. So we have this 1, 2, 3 steps for each of the question. Let's do more. Let's say this time, classic example number 2. What if we do negative 2x plus 2 is equal to 4, something like that. Let's not get lazy. We're dealing with left side first. Don't even look at the right side. Imagine the question just asking you how to open this or expand it. So that means create a table. On the left side, -2. I'm going to use the same rule, which is empty one was positive, color one was negative. So have that in your mind. I may just put that over here. It is important to let me know if you're actually doing this as a test. -1, -2. Horizontally, I have positive x, positive 2. There you go. Positive and negative give you negative. Positive and negative give you negative. Positive, negative give you negative. Same thing happened for the others. So, this is my expanded form, and I should copy that on the left side of the seesaw. Now we are at the second step, solving an equation. Instead of -2 bracket x plus 2, now we have -2x minus 4. Some people say adding with minus 4, but that's an equivalent way of saying -2x minus 4. And on the right side, I have 4. 1, 2, 3, 4. On the side that I have x, I have to create equivalent zero pair as on one that I see over here. That means I have to have 1, 2, 3, 4 positive, which I need to put equivalent amount on the right side because they need to be balanced in the seesaw. Cancel the zero pair. On the right side, I don't have any zero pairs. That means I have to stick with it. Now, last step. So, first step, second step, our last step, distribution. Is there any way I can distribute 1, 2, 3, 4, 5, 6, 7, 8 tiles to each 2 strips on the left side? Yes, we can if we distribute each of the 4 on the bottom floor and second floor to each of them. So in conclusion, if I rewrite, color strip is equivalent as 1, 2, 3, 4 empty tile. That means -x is equal to positive 4. Except we don't put negative whatever equal to. So change the sign, x is equal to -4. That is my final answer. Now, our last example of today. This time, why don't we try something that have letters other than x? So 2 -b minus 2 is equal to 6, something like that. Let's recall. First step, don't even look at the right side. We are solely focusing on the left side. And then create a table, +2, which means I'm going to use same rule, folks. Color negative, non-color positive. It's okay if you reverse it, color as positive like the previous lesson. It really doesn't matter. -b, b is a strip because it's a variable, but since it's negative, and my rule, according to my rule, it's color, so there's a color. -2, 1 color, 2 color. There you go. Color and non-color give you negative. In this case, color again. Negative and positive give you negative. When you multiply, negative and positive give you color, 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 color. So I have -2b and -4. Now, this is, like I mentioned, first step's answer, which is we expanded these complex algebraic format into simpler one. Now, second step, draw a seesaw, and you're gonna put what you find again on the left side. And on the right side, 1, 2, 3, 4, 5, 6 positive, so that's empty, 6 tile. And left side and right side should be equal. First step, 0 pair, so that I can only have strip on one of the side, which commonly it's on the left side. So I have to introduce 1, 2, 3, 4, cancel, cancel. But I have to put the same amount on the other side. Unfortunately, there's no 0 pair in that situation. Do I? Let me just quickly go through it. No, there's no 0 pair. Is there any way we can distribute what I see on the right side equivalently to each strip, so per strip? Yes, we can, giving each 5 of them to each of the strip. So that means one color strip is equivalent as 1, 2, 3, 4, 5 empty tile. That means negative x is positive 5, which is x is equal to negative 5. Switcheroo, right? In terms of its sign. That is today's lesson. Your homework for today will be again given in the blank pieces of paper. You are going to solve an equation using, solve each equation using algebra tiles. So using a tool. I'm gonna give you, because it's a complex process, or not necessarily complex, it's more steps, I'm going to give you 4. A, B, C, D, something like that. Although you cannot see much, but what I did is I put A, B, and C, and D. So you can always feel free, pause the button if you have a hard time seeing. The first question is 3 as a monomial, D minus 3 binomial equal to 3. B should be, yeah, why not? 2E plus 2 is equal to 8. C, 4F minus 1 is equal to 8. So monomial, binomial, right side. And last one, minus 2. Yeah, it should work. Negative 2 as monomial, minus b plus 2 as binomial, equal to 6. That is today's lesson.